Hello friends, we have discussed what is complex number. Today in this video we will give the concept of conjugate of a complex number. Conjugate of a complex number, it is denoted by Z bar. Let Z be a complex number, that is Z belongs to C and Z is equals to A plus IB. Then conjugate of Z denoted by Z bar, and which is equals to A minus IB. So if Z is equals to A plus IB, then Z bar equals to A minus IB. That means imaginary part, the sign is changed. For example, at Z is equals to 2 minus I, then Z bar equals to 2 plus I. And why it is conjugate? Because if you multiply these two, Z bar, it is 2 minus I and multiplied with 2 plus I. So it is in the form A minus B into A plus B. So you can write 2 square minus I square. And 2 square is 4. I square is minus 1. And minus of minus 1, it becomes plus 1. Which is equals to 5. And it belongs to set of real number. Similarly, conjugate of minus 3I plus 2 is, as it is minus 3I, it becomes plus 3I plus 2. Conjugate of minus 5 minus 3I is minus 5. So no change in real Z, only change in imaginary Z. So instead of minus 3, we'll write plus 3. Now we'll discuss the properties. Properties of conjugate. Here we are taking two complex numbers Z1 and Z2, where Z1 is equals to X plus IY and Z2 is equal to A plus IB, and I is root over minus 1. Then conjugate of Z1. As Z1 is X plus IY, so conjugate of Z is X minus IY. And then another conjugate is here, so we write it bar here. And then conjugate of X minus Y is equals to X. Now instead of minus I, now it becomes plus IY, and which is equals to Z1. Next property, Z1 plus Z2 bar is equal to Z1 bar plus Z2 bar. As we have taken Z1 is x plus Iy and Z2 a plus Ib. So, first we write Z1 plus Z2 x plus Iy a plus Ib. So when we add, it becomes real part is x plus a and imaginary part is y plus b. And Z1 plus Z2 bar is equals to x plus a, and then as it is a conjugate we have to find, let it be Z3. So Z3, conjugate of Z3 is equals to Z1 plus Z2 x plus y, now as is a conjugate, so this plus I becomes here minus I into y plus b. Now if you separate these two, x minus iy, another part is a minus ib, and clearly this one is z1 bar and this one is z2 bar. Hence it is proved that z1 plus z2 bar is equal to z1 bar plus z2 bar. Now z1 into z2 whole bar, which is equals to z1 bar into z2 bar. So when you multiply z1 and z2, as z1 is x plus iy, a plus ib, we multiply x with a plus ib, so we are getting ax, and then I bx, then iy it is ay, and then I into I square, that is minus yb. And now ax, minus yb, this is the real part, and bx plus ay. Now z1 bar into z2 bar. z1 bar is x minus iy, and z2 bar is a minus ib. So when you multiply these two, the result comes ax minus yb plus I ay and minus bx minus c. So clearly these two are equal. Now Z1 by Z2, the quotient conjugate of this equals to Z1 bar by Z2 bar. Provided Z2 not equal to 0. First we are taking let Z1 by Z2 is another complex number Z3. Now this implies Z1 is equal to Z2 into Z3. Now if you do the conjugate, Z1 bar is equals to Z2 bar into Z3 bar. From this we are getting Z1 bar by Z2 bar is equals to Z3 bar, and Z3 means Z1 by Z2. So it is proved that Z1 by Z2 bar equals to Z1 bar by Z2 bar. So these are the properties of conjugate of a complex number. Now we'll do this property. Let Z is equal to X minus Iy. Sorry, X plus Iy. And this implies Z bar is equals to X minus Iy. Now if you add this Z and its conjugate, you get X plus Iy plus X minus Iy equals to 2x. That is 2 into real part of Z. Now Z plus Z bar equals to 0. Then what happens? So if real part is 0, then Z plus Z bar is purely imaginary. Now Z minus Z bar. Z is X plus Iy minus its conjugate, that is minus X plus Iy, which is equals to 2yi, and this is equals to I into imaginary Z. And if Z minus Z bar is 0, that implies imaginary Z equals to 0, which is purely real. Now Z bar, if we multiply X plus Iy and X minus Iy, its conjugate, this becomes X square minus Iy whole square. This is equals to X square minus I square into y square. So x square plus y square as I square is equals to minus 1. So these are the properties of conjugate of a complex number. Okay, thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.